Welcome to this video on frame analysis. In this video, we will show you how to analyze complex pins. You may also like to consider this textbook with lots of solved examples and this software that will help you solve engineering statics problems. So simple and complex pins in frames and machines analysis. In another video, we have discussed the identification of simple and complex pins in frames and machines. So you may like to look at this video before you come to this one. Let's get to the analysis of complex pins. So here is an example. Here we have a complex pin where two members and a force interact, and when we have more than two interactions, the pin is complex. So what we do is we take this multi-force member apart from the pin and the two-force member apart from the pin. So all multi-force members get X and Y components at the complex pin. The complex pin here actually starts with this load which is applied here. So here is the two-force member in equilibrium. Here is the action-reaction pair of the interaction between the two-force member and the pin. And these are the two forces at the pin that are applied on the two-force member, and here is the action-reaction pair. So action-reaction pairs of Newton's third law are shown in blue. Make sure that when we put all the pieces back together, only the red support forces and the green loads remain. So if you put the two-force member back in here, this action-reaction will disappear, and when we put this multi-force member and the pin together, the Bx, By will disappear, and we will be left with only support forces and the applied loads. This problem has multiple complex pins here, here, and here. Let's draw the free body diagrams for all of these pins. These are the three pins. This pin up here has a load. This pin has a load. This is a multi-force member, so it would put two components, X and Y, force on the complex pin. Support force, two-force member on the bottom pin, two-force member on the bottom pin here, and the top pin here, another two-force member, and now this multi-force member would. Is a multi-force member, Bx, By, comes to this pin, Cx, Cy comes to this pin. And again, make sure that when we put all the pieces back together, only the red support forces and the green loads remain. Moving on. Three complex pins, two members and a force. two members and a force. So we have identified, separated two complex pins, the pin here and the pin here. The pins have these green loads on them. This is the force from the roller. This is a multi-force member. So Bx, By, Newton's third law, Bx now pointing to the left and By pointing down. Multi-force member adds two components, x and y. This is also a multi-force member. However, this is a two-force member. So let's see how they act. Multi-force member, dx dy, Newton's third law of flipped directions. Two-force member, support force here. Three complex pins here, three members meet. Another complex pin, two members and a force. Another complex pin, three members and the wall. So we are going to draw free body diagrams of this pin, and this pin. First, we look at this pin, which has a load. This is the pin on the top, and this is the pin at this support. There are 1, 2, and 3 two-force members, which are 1, 2, and 3. Force from the multi-force member, flipped direction, Ax and Ay, according to Newton's third law. Two-force member, two-force member. This is a multi-force member, Cx, Cy, Cx, Cy, we flip directions. By is the force from the roller support. Dx dy is force from this multi-force member on the complex pin. Forces from this two-force member. So only thing that's remaining here is, at this complex pin, is we have included F2, which is this two-force member, included F1, which is this force, two-force member, included dx dy from this multi-force member. So the only thing that's remaining here is force from the wall, which are Ex, Ey. Moving on. Two complex pins, a two-force member, a two-force member, and there are a multi-force member and a complex pin here. Two two-force members meet here and the wall. Force from the pin support. force from the lower pin support. The inclined two-force member. The horizontal two-force member. The vertical two-force member. This pin is the lower support, which has two two-force member and the wall in BXBY. This complex pin has two two-force members and a load. This complex pin has a two-force member and a load, but we have to include now the interaction between this multi-force member and this pin in the last step. Moving on. Here is a complex pin which interacts with two two-force member and the piston. This should be pretty easy. This is the pin support at the top. This is a multi-force member. Effect of F1 or this two-force member on the complex pin. Now we are looking at this two-force member. F2 comes here with flip direction. This is XY component of forces on the piston from the pin, and this CX-CY is the force on the pin from the piston. The other pin support, and on the piston there is a garbage compactor. We have to include two more forces, one coming from the wall and one coming from the object here. This is a complex pin. This is the tension in the cable. Tension in the cable. Tension in the cable transferred to the pin. This right angle member is two-force. So this AX-AY pair is the force on this pin here from the wall, and this is the cable tension. BXBY, BXBY is the interaction between the pin and the multi-force member. Now the last thing is this connection, CX-CY, interaction between the vertical multi-force member and the horizontal multi-force member, and the roller support. These are the tensions from the cable. Top pin support, bottom pin support, and action reaction between this multiforce member and that multiforce member. Thank you for watching.